As the name implies, this initiative is hosted by us, Infraspeak, so we're not actually going to be talking about ourselves today. Although if you're interested, we created an intelligent maintenance management platform, and if you want to know more about it, follow the link that we'll place in the chat box to the site. However, let's start. My name's Larry O'Brien. I'm the country manager for Infraspeak here in the UK, and I'll be the moderator for these sessions. The whole point of these talks is to share knowledge and experience, so please share any questions you might have for our speakers or any other comment that you want to make through the chat box, and I promise to try to give you a voice. Okay, so we want to make this as interactive as we can. Today, our subject matter is going to be the Internet of Things, and specifically the impact it will have in the HVAC-R industry. And that's why I have Jonathan and Chris with me today. So hello guys, welcome, and thank you so much for accepting our invitation to these sessions. Okay, by way of a brief introduction before the guys get to talk more about themselves and this interesting subject, I'll tell you that Jonathan's a director of Sypro. Sypro develop and deploy a variety of solutions around the built environment, combining software and sensors. These solutions include occupancy, social distancing, foot count, temperature monitoring, and other environmental factors. Okay. As well as Jonathan today, we also have Christopher, and Christopher is the CEO of Falkonair. Falkonair are specialists within HVAC-R who innovate and develop technology to reduce energy consumption, basically trying to save you money, but also drive a positive impact on the environment. So Jonathan, Chris, I'm hoping that those introductions do you justice. And now over to you to fill in the detail. So I was going to say who'd like to start, but I believe we're actually going to start with Jonathan. So please, Jonathan.
Well, thank you, first of all, for inviting me, and thank you for your time, everybody. Let's just get the presentation screen share. Can you see my screen? Let's go. Share screen. So, the impact of IoT in the HVAC industry, I suppose the first thing that we need to look at is what is IoT in the first place. And the definition of IoT is a network of physical things, objects, that are embedded with sensors and software and other technologies for the purposes of connecting and exchanging data within other devices and systems over the internet. And in our applications, it tends to be known as the industrial Internet of Things. That's because what we're doing is we're connecting things like building management systems, computer-aided facilities management, integrated workspace management, accounts packages, sensors, and what we're doing then is having control and also advanced analytics. So in essence, what we are doing is we are collecting data to provide value. So when we look at that data, what is the value of data? Well, in 2017, which seems an awful long time ago now, The Economist said that the world's most valuable resource is no longer oil, but is data. And we can see that through the likes of Google and Facebook. However, in our environment, having automated monitoring and control is like having an engineer on site with full plant and system visibility 24/7. 365 days of the year. And that is really powerful because it provides accurate, real-time and historical data that has significant value within businesses. And these values can be anything such as increasing the efficiency of the workplace, increasing the efficiency of the plant. We're able to predict when machines or plant are likely to fail. So therefore we can respond before they fail, reducing downtime, enhancing your planned maintenance and preventative maintenance programs. Also, because we're using real-time data, we can also impact utilities. So having real-time demand-side management, so we can tweak when things start and stop, so that we are reducing premium energy costs. And also importantly, the real value is to ensure that our assets are utilised to the full, so that we get better value for money out of them. So then what we're looking at is, where is all this data coming from? What are our sources? Well, there are numerous sources out there in the market and in businesses. So if we start off with sensors, sensors are now a commodity product, and we can get sensors to monitor virtually anything. But also, businesses have a vast amount of manual type of inputted data. That can be anything from spreadsheets, even PDFs. And there is value there to be mined. But within the systems, we've got our building management systems, our utilities, like your building energy management systems, SCADA for control and supervision, computer-aided facilities management, as we've already mentioned. But also, if you're running renewables, you've got a vast amount of data there. We can also look at what's going on in the accounts, in the customer relationship management packages, and any sort of manufacturing type of information. So we've got all these different sources of data. The question is, where is it all, and why isn't it being used? Well, part of the problem is the fact that it's spread across a broad range of disparate platforms. Each of these platforms have their own historians or libraries of data, and frequently they don't speak to each other. And not only do the systems not speak to each other, but the people who are using them don't speak to other people within the organisation, because it seems to be a specialist area. Yet, with that specialist data that we've got, that can impact every element of our business. So what we need to have is something that really does incorporate what IoT is all about, which is the purpose of connecting and exchanging data with other devices and systems, with the primary element is to extract value. So where is the value? Well, let's start on the HVAC side of things with predictive maintenance. Well, we're able to monitor the hardware, the motors, the pumps, the heat exchangers, everything there we can monitor. And frequently it's already got sensors there or devices there, and we can access that through the building management systems. Also, because we're using software and it's cloud-based, we can have every location that you've got in your portfolio sort of connected, which means whether you are a company with multiple sites or whether you are a maintenance company with loads of sites because of the contracts that you've got, you can see what's going on, you can visualize what's going on at every location in real time. And importantly, you've got your automated alarms and actions. Now, these alarms can trigger maintenance call-outs via Infraspeak. And what you have there is the fact that you know when something is beginning to happen. You know when a motor is beginning to draw more energy, for example, so that you can go in and fix it. And so therefore we come down to the predictive analysis. And as we predict what's going on, it means that your teams can get out there, resolve them before they actually break down. We can monitor and report on the key component reliability. So therefore, it means that you can start using your show how reliable they actually are in their duty cycles, during their duty cycles. And all this comes to the key elements that what we're doing is we're reducing downtime and reducing the number of man hours that are required due to the fact that we're not getting breakdowns, plus the fact that we are also not having to have so many call-outs. So that's one element of value. The other element of value is the environmental side. Now, within utilities, it's important that what we need to do is we need to reduce and optimize our energy and water consumption. The consumption is important because we want to get down the CO2 down. And we can use IoT to be able to do things such as load shifting, and also looking at where there is wastage. And so we can draw out not only the cost of the number of kilowatt hours that we're using, but we can also then start looking at reducing cost in addition to the number of kilowatt hours we're using. And importantly, we also can be assisted in our ESOS and ISO 50001 reporting, because a lot of the data there we can get in real time, and it saves an awful lot of management time bringing that information together. And not only that, when you've got real-time data, you can start bringing the information into the level of granularity that you need. So whether you want it by your property portfolio or by your piece of plant, that's fine. We can do it. And importantly, again, when we come to water is something that we can't do much on regarding pricing and cost. However, we can identify when there are leaks, because leaks are costly. And so we can use either data from water meters, or we can put sensors in, and all these things will help us identify whether we have an issue with our water utility. Internal environments are really interesting, because when we start looking at occupancy, we're looking at space management, but also we then start looking at pollutants. So whether it's carbon dioxide, carbon monoxide, or VOx, they all play a part in the performance of the team who are working in that environment. Plus, so does temperature, humidity. And so having alarms to say that things are going out of whack is a very good way of monitoring what's going on in that facility, and coupling that to controls. I've already touched on waste, so we'll move on. So when we look at the performance, what we're looking at when we're using IoT, when we're using the analytics platforms that sit behind IoT, when we look at the controls that can sit behind IoT, what we're looking at is maximizing the performance of our building services. So, for example, in the current COVID scenario, we've got a client who is currently cleaning they're in hospitality, they're currently cleaning their toilet facilities at least every hour, if not more. Most of those facilities that they're cleaning every hour probably only need to be cleaned once a day or twice a day. But because they're in hospitality, they're covering that. And so what we've been able to do for them is to provide an IoT solution that means they know how often those toilets have been used, and therefore they can then start rationalizing the cleaning protocols so it fits, and that is enhancing their performance. With plant, for example, with the HVAC-R, we can look at how well the compressors are working, for example. With energy, are we hitting our energy targets? Are we wasting energy? Are we getting it what we're expecting out of our renewables? We've already touched on wastage of water. And then when we come to utilization, with occupancy, what is the utilization of all these other resources like cleaning, maintenance, energy consumption versus the occupancy? So are we out of line? Are there ways that we can be more cost effective? And also, when it comes to the utilization of plant and what have you, are there external influences, for example, weather, which has a big impact? And are there ways that we can mitigate things? So then, if we start mitigating things, what we need to do is be able to also, in very quick time, monitor the impacts of those changes that we've made. And that can be in terms of breakdowns, utilization, and energy costs. But what are the impacts of doing nothing or of poor performance? Well, the direct impacts are will either maintain an increased level of breakdowns rather than what we could be achieving. Our utility costs remain higher than they might well be. Our time to fix on critical alarms will remain where they are and not reduce. Call-out charges will remain high. Service disruption and production disruption will be there, which has an impact on revenue. Because if our service is disrupted or if our production lines are disrupted, that then affects our clients. So then if you're in the hospitality sector, your question then is, what is the TripAdvisor going to be saying? Because something's gone wrong, and then you start getting bad reviews. Not good. And also it means that you have higher maintenance costs that you should really be having. Interesting on staff performance, there has been research out saying that poor environmental conditions like temperature, humidity, pollutant, CO2, CO, VOx, has an impact on productivity. And that impact can be over 50%. So that's a huge amount of really undocumented lost performance. Whereas if we get the environmental conditions right with our HVAC, then productivity will remain high. And also space costs money, and if we're using it inefficiently, that has a general impact on everything that we do, because with all those impacts that we've had, we've just said that there's a lower return on investment. So what we need to do is bring it all together, bring that information that we've got from all those disparate platforms and sources that we've got, and we need to bring them down so that they're visible in a single portal, which we call a single pane of glass, or a SPOG, horrible expression. And that brings visualization of data for individuals in a way that they get full sight of everything that they need, and they're able to drill down into each system. And what's more is they're able to do controls from within there as well. So if they want to adjust set points or do a test of the operation, or they want to do something, change a set point manually or automatically, they can do it from anywhere in the world. And importantly, you've got your alarms, and you can set your alarms via the portal as well. And those can be via SMS, email, SMS to voice. But importantly, if you've got an alert or a change in your data, you need to be able to put notes on that data so that you've got context, so that you can read that information from the context. And what we can also do using Infraspeak, those alarms can then trigger works orders, such as inspections. And the one issue that we have with alarms is frequently alarms are set at a level where they are too frequent. They're coming in too often, and a culture of ignoring them develops. And so what you then need is, using the technology behind all of this, is to triage those alarms. And so then you can start adjusting the alarms so that they're at the correct level, but also you respond to the critical alarms at the right time. And obviously you need your reporting from your alarms. So let's look at a few HVAC-R specifics. First of all, we've touched on energy consumption. So there's load shifting. Can we turn the heating on half an hour later, for example? Or can we turn the temperature down a degree on the heating and see what reaction we get out of the staff? If there's complaints, we knock it up a degree or half a degree. And so what we're doing is, all the time we're looking at trying to shave off energy. But also, when we load shift, can we, for example, heat the room or the building at a certain time before a premium charge comes into place, and then crank down the boilers from there, or the aircon from that point, so that we are not burning as much energy in those peak times, because DUOS in certain areas can be more than double your normal energy cost. And so we can establish these cost-effective temperature regimes, and we can monitor them in real time, and we can see the responses from people. When it comes to maintenance, we've got real-time plant performance. We can see immediate out-of-range anomalies. We can get a reduction in the reactive call-outs, which is a big cost. We can assess individual plant performance, as I've already mentioned, but importantly, we can automate the audits from real-time data. So, for example, with Legionella, and we can have a large amount of the data for ESOS or for ISO 50001 or any other form of management reporting automatically generated. So it's saving a large amount of management time. So if we look at a case study, property management, the challenge for the client was they had increasing energy costs. They had a high level of reactive call-outs, limited space, and a very high maintenance cost. So our solution was to monitor the plant, the occupancy level, the energy, and how the facility was used. So that way we could optimize the space usage, change some of the processes within facilities management, and look at the way energy was consumed. There were alarms which escalated, and again we had the single portal for reporting on multiple systems. The result was staggering. We had an ROI of within a year. We had reduced energy costs of between 10 to 18%. And for every pound of energy that's saved, at least £2 was saved in operational savings. We had dramatic savings on time to fix, on calls and call outs. And so overall, it was a fantastic project in the fact that it did everything that was said on the tin, it achieved. So Chris is going to be talking to us regarding HVAC-R, and what we do for Chris is we monitor the performance of the existing systems and the Falkonair systems to make sure that they are performing, and also highlight whether there are any issues, for example, increased pressures, and we quantify what savings are, whether they be in monetary terms, CO2 or kilowatt hours. And it means that his clients can see wherever they are in the world, by authorized users, what's going on their system. So to wrap up and summarize, IoT has many benefits for the HVAC industry. There's real-time visibility, real-time control, savings in maintenance costs, reduced call-outs, reduced time to fix, utility savings, staff performance and productivity increases, reduced performance in times, and visibility. But those are just a few. The impacts of IoT within HVAC are huge and will benefit everybody. Thank you so much for your time, and I'm going to pass over to Chris now.
Thank you very much, Jonathan. And here's Chris. Chris, your mic is muted at the moment. You would have to unmute yourself. You're still muted. Okay, if we just give Chris 1 minute to try and sort that mic out. I was just going to say, Jonathan, thank you very much for that session. I mean, the case study you touched on at the end there, we'll go through this in the discussions, but the case study you touched on there was overwhelmingly positive results. I can see Chris's mute sign is off, so I'll hand back to Chris. We still don't have audio there, Chris. I think somebody's just trying to sort that out in the background. So if somebody could give me an idea when it's fixed, I'll just continue with Jonathan for a moment. Right, Jonathan, so you were just saying that case study there. I mean, it was overwhelming, everything from reduction of costs, saved maintenance charges, reduction of energy, more efficiency in terms of the utilization of the assets, etc. Is there a downside?
The only downside really is how granular do you want to go? Because if there are gaps in the technology or in the sensors, you've got to spend some capital and putting some new sensors in. So apart from that, again, information is power, and the more data that you can get, the more the impacts on your business will be. But what we tend to do is start at a high level and then go more granular as time goes on, rather than banging in everything that you've got and everything that is possible at the outset, because you may well be wasting money at that point. What you want to do is start at the top with the systems that you've got, then identify where your gaps are. And then as you start identifying your unknowns, you can start tackling them and then enhancing your data collection from that. So it's a continual process. It's not something that you'll put in once. It's not something that you'll put in once and then just leave. It's a continual process.
Yeah, it's I mean, it's a proper thing, because the way you're looking at it is, once you've got the sensors in place, made sure there's no gaps, you're taking action accordingly, then you can start to fine tune based on the results you're getting, what you're looking at and expected performance from every sensor, so you get more just in time opportunity from a maintenance point of view, which makes all the difference in the world. I mean, I know people talk about predictive maintenance, but and it's a good term to use, but the sensors, I think, just enhance what you're doing in maintenance in terms of it being just in time. Actually, only doing maintenance activity when you need to do maintenance activity. So it's excellent.
If you've got, we have another case study where we were monitoring sterilisation units within a pharmaceutical company, and their problem was that the motors were burning out because the fans were sort of releasing as the fans ended up they were vibrating, so steam would come out. And so there was a rise in humidity, rise in temperature, and that burned out the motors. And that was costing them £500,000 a year. And and we put in a very simple system, which was just purely to monitor humidity and temperature. Rather than looking at vibration and acoustics, which is expensive, we just did the absolute basics of the condition. Because if you were looking at vibration, the problem had already arisen. The things were beginning to wear. And so by looking at the conditions, and what we were able to do was completely eradicate burnouts from humidity and that. And the payback was in 3 months.
It's amazing when you think what you can do, and that is a perfect example of just fine tuning. Rather than dealing with the actual problem, you were going back and looking at what the cause was and taking it that step further. I think he's back on. I don't know if he's got audio or not yet. Chris, can you hear us? Can you speak? It looks like we've still got a problem with both audio. All right, so I'm guessing he can hear us from that reaction, but it looks like he's not able to speak as yet. Okay. Chris, not a lot I can do for you at this point. What we'll do while the guys try and sort that out with you, it's a typical thing. I'm in the world of software. This is what you call a software demo, It happens. And our audience have all recently had Zoom or Team or Hangout meetings where something went horribly wrong. So this won't be any strange occurrence for them, and I'm sure they're all feeling very sympathetic to you right now, but also having a good old chortle. So let's see if we can get this sorted, and I'm just going to chat with Jonathan, about a couple of other things that we would probably have come up in the discussion. At any point in time, please join in, and then we'll swap to your segment. Okay? All right. So, Jonathan, there was a couple of other bits you were talking about there, and how can I say? I'm a fan of use cases.
Yep.
So I love use cases, things like you were talking about the hospitality customer. And I'm guessing that you're ranging in there the toilet cleaning thing. Are you basing that on foot traffic? So the
Yes.
best on the volume of foot traffic means do it once an hour, do it once every 3 hours, or do it now. Yeah.
Yes. The interesting thing with the toilet cleaning element is, with that regime, the client is spending a lot of money because they're having to reassign resources to clean far too often. And so what we're doing is we're monitoring the number of people going into the toilet facility. But we're also monitoring the number of people who are going into cubicles, believe it or not. We're not seeing them going
Big Brother is watching you at the bathroom, is what you're saying.
Yeah. And so that way, there's a number of things that we can do. First of all, we know what facilities are being used most. Also, we know when the cleaner goes in, have they got into every cubicle and done their I was going to say done their business in the, but so have they done their job in the cubicle? But the other thing that we're doing with that is we've also, as you mentioned, we develop hardware. We've got a system now for sanitizing the toilets as well, so that it really does come down to the fact that the cleaners only have to go in when there's a certain number of users been in there in the cubicles. We know which cubicles they've been in, and they can go in, check the toilet paper, make sure the place is clean, and all of that. And that's reducing their costs quite dramatically.
It's interesting when you look at things like that, Jonathan, because most people, we, from an Infraspeak point of view, we talk about maintenance heroes because we think that the maintenance people, the cleaners, everything like that, are undervalued a lot of the time, and we call them maintenance heroes because nobody complains when the air conditioning works 364 days of the year, but the day it fails, everybody's jumping on the phone. So actually being able to keep things up and running, but you take that simple example you use from the cleaning, the footfall count, and you take it to the other side. You take it to a ballroom and you count the number of people coming and going from a ballroom, and suddenly you could get people going out and doing health and safety checks, which they've already done before the event, I know, but again, to check that the fire exits are clear and the fire doors are there and the throughways are all clear and done. So there's so many applications of something as simple as that footfall counter, whether it's cleaning, whether it's health and safety, etc. And then, as you said earlier on, occupancy, who's using the meeting rooms? Are too many people in them? Are people booking a meeting room for 12 people and there's only 4 in it?
Yeah. And the other part with when you're looking at occupancy and usage is our sensors on occupancy can also identify whether a table is clear. So, have someone got it? Have you had the meeting? Everybody cleared out and left their coffee cups on the table.
Yeah.
And so that can then trigger an alarm or an alert to the cleaning staff to go in and clear the table, or to the manager to say, "Excuse me, your team have left this in a terrible state."
Yeah.
The other thing that we can identify, which if you are in sensitive areas, is that, for example, if you've got a whiteboard or a flip chart, whether you've left data on the flip chart or if it's clear. So if you've got sensitive data, for example, you're in a local authority and they've got client information up on the wall, which no one else should see because it's data protected, you can have an alert saying, go and clean down the whiteboard because it's not empty. So there's really clever type of stuff. And then going back to your ballroom example with the sensors, we can also then tie that up to see, okay, what's going on with the bars, with the number of people in here, how much alcohol, or how many drinks are being sold, for example, are the ways that we can maximize revenue.
Yeah, No, I understand. I mean, our experience of working with yourselves and other organisations on the Internet of Things, as you say, it's an industrial Internet of Things. It's about how you can. We often talk about making dumb assets intelligent.
Yeah.
You know, because you can take an air conditioning unit and suddenly have all of the history, all of the plans, all of the power utilization metrics from it, measurements on temperature, measurements on vibration, everything under the sun. So you can optimize the life cycle, and the asset is helping you do that. You optimize that life cycle. And one of the things we do is we look at the economic analysis, and you can make informed decisions of when you reach the point that actually you now need to do something about this, because it's going to cost you more to maintain it than it will do to replace it. So
the thing I like about Infraspeak is when you've got all that data coming through, is not only are you looking at the life cycle of the asset, but also you're able to tell procurement and engineering, you don't really want to buy this type of asset because it's not cost effective to run.
Yeah.
Whereas this manufacturer is far better.
Yes.
Based on usage. And then that gives you a much greater power when it comes to your buying power.
It's interesting. We have a customer who's a manufacturing environment, and they were able to understand that some of their older machines that had been much more expensive and technically should have cost them a lot more to maintain were actually costing them a fraction to maintain in comparison to what the new machines they'd got. In fact,
Can you join again, please?
Hi, Liliana. We can hear you.
Yeah. Oh, you can hear me now.
We can hear you, Chris, and I can hear Liliana as well. Excellent. Oh, and now he's just went on mute. Chris, can you hear us?
Can you hear me now?
Now you can.
Yes. Okay. Excellent.
Sorry, guys.
No, Chris, it wouldn't be a presentation without technical.
Yes. So you can hear me. Sorry about that.
That's okay.
Sometimes these things happen. I don't know how.
Right, I'm going to go on mute, Chris, and let you do your piece now, okay? I hope everybody bears with us. We're going to run a little bit over today, so thank you for your patience, folks.
I'm going to share my screen now. Okay, I'm assuming you're seeing my screen, right? Can you see my screen? Yeah. Hello?
Yes, we can see it.
Yeah, okay. All right. So thank you, guys. Sorry for the trouble there. I would like to present to you our technology that we innovate continuously for the HVAC system. So the key use of IoT is clearly breakdown cost and energy savings is equals to environmental gain for our children's future. We all know that if we are avoiding breakdowns cost and equals energy savings, because if you are having breakdowns, we can combine them together by having an efficient system working, but at the same time avoiding breakdowns cost. At the end of the day, we all know for the industry, breakdowns cost can be considerable high, sometimes even oversees brand new systems sometimes. So with the energy efficiency strategy and the IoT monitoring your systems, then you can avoid breakdowns. And at the end of the day, we are gaining for our children's future. So how can we manage this? Our technology is already out there. So our systems are already intelligent. They are controlled. So this is an example of a VRF system, which has got all the red dots there. There are all sensors connected to the main motherboard. So all of this knowledge and all of this data is available already in our systems. All we need to do is to link it out onto a system like Jonathan provides onto a cloud, so then we can monitor to see our system, how healthy it is working. So our innovation from Falkonair is a smart compressor control, which is a patent pending product. And we know that we are, okay, I'm being told that my screen is not moving.
Chris, I think you might have shared the slide rather than the presentation screen.
Okay.
If you're in presentation mode, yeah.
Yeah, that's what I'm sharing. I'm sharing this slide.
And that's it now.
It's moved now, Chris.
Okay, I think there's a delay. That's the problem. Okay. There is a big delay.
Don't worry, we'll get there.
It's not moving, is it?
I'm seeing key use of IoT.
Yes. Yeah, it's not moving.
Okay.
I would need to
Okay.
move it this way. For some reason, this never happened to me. You know how many presentations I do?
I can imagine. I can imagine. It's one of those things, isn't it? It's just sometimes it happens.
Oh, yes. Some things.
Chris, would you be comfortable talking through it, even if you can't show the slides? Would that be the easiest way to do it, my friend?
Sorry about that.
No, that's all right. We'll listen. Thank you.
I don't know what's happening today. This never happened. So going through our presentation, let me see if I can get it done through here. Yeah, I think what it is, my computer's got so many virus checks.
Just talk through it, Chris. That might be the easiest thing. You know, we can imagine the slides.
So the what you're seeing on your screens now is all the red dots on your screens. It's a system which all of those sensors are already communicating with the main board of your system out there. So all we need to do is pick those sensors, pick that data, and send it onto a cloud like Jonathan is presenting, which from there we can create a preventive maintenance before the actual fact happens. So what Falkonair is innovating, which we are innovated, it's a smart compressor control. It is a patent pending product. And we've recognized the problem in the industry that if we can retrofit on your existing system, whether it's a fixed speed or a refrigeration system, we can not just save you energy, but give you an option of preventing high cost of breakdowns. So our SCC, we know that the problem is the HVAC systems are made up of efficient systems. But I know as well that they are running inefficiently. And this is where the problem all goes wrong. Because everybody can buy the most efficient system in the planet. But I know for a fact, because I travel all over the world, that 70% of those systems, they are very efficient when they leave the manufacturer, but unfortunately, because they are installed, that's when they run inefficiently. So what we've created, our smart compressor control, is if you have one of those systems, our smart compressor control would not let that happen. If your system is either short of refrigerant, haven't been commissioned properly, you have anything not right with your system, our controller, our smart compressor control would actually tell you, and not just send you an alarm, but would actually tell you that the behavior of your system is abnormal. So our system is purely made for the unintelligent systems out there who are sold as large fixed speed systems, fixed speed compressors, and refrigeration systems, which we know that a lot of those systems are controlled by pressure. What I'm telling you now today, I know there's going to be a lot of people saying that I don't know what I'm talking about, but believe me, the most efficient systems on the planet are VRF, and they're all controlled by temperature sensors, not pressure sensors. Pressure sensors are only on a VRF or a DC inverter system is to maintain, not control, and to see what the system is doing. When it comes to control, it's all gone by temperature. And the simple reason is when you are modulating a compressor, a refrigeration system, it is very likely that your pressure and temperature do not align according to your pH diagram. So if you're using pressure control on your system and you assume that if the pressure is this, the temperature is this, that is a bad assumption, and that's how people are consuming loads of energy and breaking compressors. I've seen this a lot of times, and I still see it being designed and being sold on the market today. But we've moved forward, and I can see that we are the leaders in this technology, and our product is purposely for that. We do have integrated alarm systems. We also look out for the discharge temperature going out of the compressor. So if there's any abnormal heat on our compressor, it will either stop your system or send you an alarm. And thanks to Jonathan's technology, obviously, we can outlay all that monitoring that we are monitoring on our SCC. Okay, the slide is not moving.
So basically, Chris, you're monitoring heat, temperature, and pressure.
We are monitoring temperature and pressure, but we are controlling only by temperature.
Right, okay.
So, yeah. Okay, the next slide. Okay, so the next slide, when it comes up, when it decides to come up, there it is. I think there is some kind of delay on the system. So the next slide is purely showing the benefit of what we are doing out there in the real world. Apart from increasing the energy efficiency by up to 30% on any refrigeration fixed speed system, we are reducing compressor failures, because obviously now, if we're looking by temperature, if we're monitoring by temperature, the suction and the discharge of the compressor, we are definitely reducing compressor failures, because that is the only way you can reduce those compressor failures. By pressure, you can only monitor. But when it comes to control, it's very important to control by temperature. Reduce downtime, obviously, because we are breaking less compressors in the industry. We are reducing spoilage. I would love you to get this slide when it decides to come on, but it doesn't want to transmit for some reason. So we are reducing spoilage. The reason is that we've seen, and I've seen personally, so many refrigeration systems running short of refrigerant, but the customer would only know and realize that his system is running short of refrigerant when he starts to lose produce. Because they are all controlled by pressure, the pressure sensor would not know that. It has to be really low on refrigerant when it decides to shut down on its low pressure cutout. That is the fault when controlling by pressure. If you're controlling by temperature, however, the system would know that there is something not right with your system. Your suction temperature is coming too high into the compressor. So then that's how we throw out an alarm to the customer and tell them you've got something not right, whether you're short of refrigerant or there is anything wrong with your system, we would know, because your temperature, not your pressure can come back low, but your temperature can still come back high. It's just purely because you are short of refrigerant. Clearly, this slide doesn't want it. And gents, that is my presentation. I'm sorry for this confusion.
No, Chris, that's perfectly all right. Perfectly all right. We've all been there, so it's just one of those things. But thank you for persevering and trying there. I do understand where you're coming from. Like Jonathan, really what you're alluding to is by putting those controls in place and working on what you're monitoring and how you're monitoring, you really can both drive power usage down, therefore spend down, but you can also optimize the life and the life cycle for the asset. Yeah. So yeah, no, very, very clearly understood there. Yeah. I'm conscious of the fact, guys, that we've actually only got a few minutes left out of our allotted time. So was there anything else you gents wanted to discuss? Is there any particular trend within the market as such at the moment that you think we should be aware of and addressing?
I think there's a driver in the market at the moment, and that is fairly obvious. It's the driver is how do we extract cost out of businesses, because we're in really tough trading times.
Yeah.
And I think that is the part where, for example, Chris, myself, and you, Larry, the products that we offer enable clients to really look at driving costs out of their business, and also managing their risk, because again, failures is a risk, and what we're able to do is manage that risk for our clients, and again, make sure that not just the software and what we put in, but that their whole plant achieves the ROI that they're expecting.
Okay. And Chris, your comment?
Yeah. The only thing I would like to say is it is a breakthrough that finally we have something like that. We know that with all this data collection, it's still not enough. Data collection is good, and to prevent maintenance, it's really good. But the other important thing is who's on the other side of the monitoring. So it would be, and obviously we are all advancing together, that we are creating an algorithm. So like Jonathan said earlier, there won't be false alarms.
Yeah.
You cannot always identify the exact problem, but I've already seeing it in a lot of different countries where they are preventing people going out to call outs, which it won't be a call out. It would just be waste of time and waste of money. It's simply because a customer switched off something.
I understand.
So,
I mean, I think the thing that links all three of our companies, this is my personal belief, is innovation. I think where we work very well is with anybody who's starting to think that bit further forward about what they want to offer, where they want to be, how they want to move forward. I mean, you guys, Falkonair, being innovative in what you're doing in terms of being capable to retrofit to existing systems. That's brilliant. Utilizing the Internet of Things and the sensor solutions that Jonathan was talking about, and then being able again to fit, to flex and use that with a system like ours and integrate the entire piece so that you can optimize the energy, they can identify any performance issues, we can get that engineer out that Jonathan said is like having an engineer 24/7 sitting at your premises. These are really, really critical things. And I think organizations that want to move forward and want to save themselves a certain amount of money, 2, want to have an impact in the environment, but 3, might want to differentiate themselves by actually looking at the innovation and seeing what the possibilities are. I think those are the kind of people you really want to meet and engage with, aren't they?
Yeah.
They're the forward thinkers. So gentlemen, I am going to take the moment to wrap this session up. I mean, I'll start off by thanking you both, Chris and Jonathan, and especially Chris for working through that problem and the great insights you've shared today. Okay, I've learned from this session because there's a couple of things came out of it that I hadn't quite put together, especially the retrofitting. So that's brilliant. And I hope that our audience has got their own takeaways from this session, because at the end of the day, that's what it's all about.
Yes.
So as long as they've got that, mission accomplished. I will say that we are still available. I've not actually picked up any questions from the audiences yet, and I've just checked. We are available to answer any questions that might pop into heads later on. You can contact us individually through our LinkedIn profiles. We'll leave those on the chat box for people to get, and you're welcome to drop us a message anytime. We will also in due course publish a recording of this session, and we'll include with that the contact points for all participants. In the meantime, if you fancy subscribing to either our LinkedIn page or going to talks.infraspeak.com, that will ensure you get notified about when that video is available, and also find out about all the other talks that are going to be in this series. The next UK session will be on the 8th of October. It's about opportunities and challenges in the cleaning industry. And remember, and check the chat box again for all those links. I'll allow each of my co-presenters here to say cheerio to you, and we look forward to seeing you soon.
Thank you, guys. Thank you, everyone.
Everyone, we really do appreciate.
Yes.
And
thank you.
We will be closing down